Okay, and the last thing with alternating series, before we kind of switch gears a little bit in this unit, is the alternating series error bound. So if a series converges by the alternating series test, then the error from using the first n terms of the series to approximate the value of the series is less than or equal to the absolute value of the first omitted term. So what we have here is the error is equal to the absolute value of big S minus S sub n. And if we remember from before, this is the actual sum minus the partial sum. So nth partial sum. And this is going to be less than or equal to the absolute value of a sub n plus 1. And this is whatever the next term would have been. So whatever your nth partial sum, the next term. So say we have a series, it wouldn't be this because obviously it would be alternating. But if we had the series 1, 2, 3, 4, and I looked at that first 4 partial sum, our next term would be that 5. It would be less than that 5. So it's not that in this case because it's not an alternating series, but that's the idea of it. So given the series, the summation from n equals 1 to infinity of -1 to the n minus 1 divided by n, find S sub 5 using the alternating series error bound, find the lower and upper bound. So what we're going to do first is we are going to find S sub 5. So S sub 5 is equal to, so our first term, we're going to plug in 1 for n. So 1 minus 1 is 0. -1 to the 0 power is 1. So we have 1 over 1, which is 1. And then we started with a positive, so we're going to automatically go to a negative because it's an alternating series. And so now I know my pattern of alternating series, so I can kind of ignore that top part. So now we're looking at the denominator, so we have 1 over 2 plus 1 over 3 minus 1 over 4 plus 1 over 5. We want to add all of those together. So 1 minus a half plus a third minus a fourth plus a fifth. And if we figure that out, this is approximately 0.783 repeated. So that 3 is going to be repeated forever for what we have here. So I'm going to leave it as 7.83. So what we know is that our error is less than or equal to a sub n plus 1, that absolute value. So when we're looking at that means is our n in this case is the number 5 because it's the 5th term. So our error is less than or equal to the absolute value of a sub 5 plus 1. So a sub 6. A sub 6, we just had plus 1/5. So our next term is going to be negative and 1 over 6. So negative 1/6 is the kind of cap here. So negative 1/6 is our absolute value. So our error is less than or equal to 1/6. This means the biggest our error can be is 1/6 above our number and 1/6 below our number. So 1/6 is about 0.16667 because the 6 repeats forever. So we're going to use that as kind of our thing here. So what we know is that if this is our approximation, because it's the sum of the first so many terms, it's off by, at most, this much. So it's off by that much on both sides. So our lower bound and upper bound are going to be this number subtracting by 1/6, or this number and we add 1/6. So I have 0.783 minus 0.6166 less than or equal to our actual sum S, less than or equal to 0.783 plus 0.166. Okay, if I simplify that, we're going to get 0.616 less than or equal to S less than or equal to 0.9 94, but it's pretty much 95 because they both repeat on forever. So we're going to go 0.95. So what we have here is our partial sum gave us 0.783, and we know that our actual sum is that 1/6 in between there. So our actual sum is somewhere between these values, and that's actually really cool because we can have an alternating series that we can't actually find the sum of, but we can kind of really get a good estimate for it when we look at so many terms together. And the more terms we look at, the better approximation we get. Okay, so sine of 1 can be written as this following sequence, or this following summation of terms. So we have 1 minus 1 over 3 factorial plus 1 over 5 factorial minus 1 over 7 factorial plus, and that goes on forever. This is kind of like a sign of things to come, just as a heads up. Approximate sine of 1 using the first two terms of the series. So our first two terms, when they're talking about, they're going to talk about non-zero terms. So sine of 1, looking at what we have, is about, our first term is 1, our second term is minus 1 over 3 factorial. So that's what we're going to use to approximate it. So we have 1 minus 1 over 3 factorial, which happens to be 6. So we're really looking at 6 over 6 minus 1/6. So 5/6. So S sub 2 is equal to 5/6, which is the same as 0.83 repeated. Find the maximum error guaranteed by the alternating series error bound when using the first two terms. So when we're looking at this, we know our error is less than or equal to the absolute value of a sub n plus 1, that next term. So if we look at what we have, our error has to be less than or equal to the absolute value of a sub 3. In this case, a sub 3 is that 1 over 5 factorial. Well, 1 over 5 factorial is already positive, so we have 1 over 5 factorial is 5 times 4 times 3 times 2 times 1, which is 120. So 1 over 120. So this is our max error. So this is one of those things that's just an interesting tool that we can use for these different things, but it's another one of those things that you have to know what it's asking for and know the formulas for it. So it makes it just a little bit more difficult.